Hey guys, Sobi Kenobi here again with Gowinvest 201, lesson 3 now. We are talking about options Greeks. It's going to be kind of a short lesson today. This is just the basis of what you need to know when you're getting into an options. If you want to compare, say you have two stocks and you want to compare their options because each of them have different implied volatility, different machinery that kind of goes beyond them, and you wanted to compare these two options. You have a call option for, say, Apple, and you have a call option for Microsoft. Which is the better one to take based off of just the data alone? And that's where you get into viewing option Greeks. Okay, guys, so today we're talking about lesson 3, options Greeks. Okay, yes. So you might be asking, what are options Greeks? Well, if you ever try to trade any options, say on Robinhood or Webull or something like that, you might see a little section at the bottom talking about delta, gamma, theta, vega, and rho. And that's what we're here to explain today. Like, those are the underlying factors in pricing an options contract. A lot of people really don't take them into consideration because it's really more so the price, but it's good to kind of understand that these are the factors that affect it. So you have delta here, you have gamma, you have theta, and you have vega, and you have rho. Okay, so rho we're not going to talk about because that regards the interest, N-T-E-R-E-S-T, rate. And that is in the case you are doing some selling of contracts and you provided some collateral. So it's not that useful, and even with pricing of a contract, it plays a very small factor into the contract. So delta, the biggest one, is the rate of change of the price of a contract. And the way that it's kind of stated is, like, let's say you have a $150 call strike, and it's currently trading at 145 bucks. Okay, so if it's trading at 145 bucks and then it goes up to 146 bucks, and say your delta is 0.5, and you bought the contracts at $1.25, the $1 that you go up will be now at $1.75 because it went up by 50 cents, and that was your delta. Now, when it goes up one more to 147, you realize that it is now going to go even higher. So instead of saying 225, it might go to 235. And you're like, well, the delta changed from 0.5 to 0.6. And why did the delta change over here to 0.6? It's because that, say you have an options contract, while it's so far out of the money, it's going to be worth zero. Basically nothing. It's hard for that. There's a very small chance that that will ever be worth anything. As soon as you get close to the strike price, it goes up in this exponential fashion. And then after your strike price, it's pretty linear. So this is the value of a contract, and this price is where the delta goes between 0 and 1. So the highest delta you can ever get is a 1. The lowest delta you can ever get is a 0. This is on a call option. So the call goes from 0 to 1. For a put, it goes to 0 to negative 1. And the reason being is it's basically just saying that your delta is going in the inverse direction. So here it goes up. In the other case, it goes better when it goes down. So a negative delta really means that as it goes up, you lose money, and for a put. So in our case, we have to take the inverse of that to be negative. So you can see here, this is the calls. It has a positive delta. If you go to a put, it'll have a negative delta. Okay, so to really see the probability, you'll probably have to do 1 minus the put. So it can also be said that the delta here, can't see where, so my delta here is the probability I'll be in the money. Contract ECTITM. So people say that if you have a delta of 0.7, that's an ideal scenario, and that should be like it'll be in the money soon, and you should always play around a delta of 0.7. Now, what is the gamma? The gamma is the rate of change of delta. So like we said here, it doesn't stay the same. It went up by 0.1. So 0.1 was the gamma at this stage. So it says, okay, I'll increase by I'll increase the price by 0.5, but my acceleration is 0.1. So now my delta is going to be 0.6 for the next leg up. And then even this will increase by a certain amount. So that's the gamma. It's not useful for a lot of things. People don't take into consideration as much as delta. But theta here, theta is time decay. And it also goes between 0 and 1, where as it gets closer to 1, it decreases in value faster. I think it's per the hour or something like that, but we can see here that if we got a theta, it's already decreasing. Okay, so it's between 0 and minus 1, not 0 and 1, but 0 and minus 1, and that's how much it decreases by. So for contract that ends up in, say, July 9th, our theta is 0.37. So we're losing about 37% of our contract day by day. Versus, say, we do something that is way out. I think it's by the week. It's not by the day. But then it'll be minus 0.1865. So now we're only losing 18% per week. And then you can go out further, and you can see that that theta just decreases a ton. So that's something that you can easily talk about. Its theta decay is your time decay, and you can see if it's greater than 0.3, we might be in trouble for the weeklies. Weeklies really just mean they expire by end of week. So then we talk about the Vega. The Vega is implied volatility. All right, it changes on expiry because we talked about how there's high variability in the stock at the beginning and then low variability in the stock at the end, but it's really based off of the bids and asks for the implied volatility. So you can see Vega's here. They have a low value and they'll only decrease as you go closer to the things. So like out of the, as far, if you go out, you have a lot of chance for variability, so 0.06. But as you get closer to expiry, this goes to 0.02, so it's a lot less volatile than if you go out. If you go out, you have more volatility, more chances of increase, so your Vega is higher. So these two things are extrinsic value, and these two things both denote intrinsic value, but also a little bit of extrinsic value. And that's because right here, this is below the strike. It doesn't matter that delta is going up. If it goes up below the strike, it kind of hits this speed bump over here and jumps up. And so that is the this is still extrinsic value. It has no intrinsic value until it crosses strike and becomes linear. And delta is equal to 1 or close by it. Okay, so those are the options contracts, Greeks, and that's kind of how you look at it. You basically look for things that have deltas of 0.7. That's going to be close to in the money. And you look for a Vega of less than 0.3. So you want it less than 0. Or theta less than 0.3. If you have those two factors, those are the two things that you really have to consider. Vega really changes per stock, so you can't really use it as a metric. You only use it within the stock to maybe find volatility. But yeah, these are the two main factors. And as long as you see these on particular stocks and weeklies, then you might consider playing it. So that's a good check to have. So next time we are going to talk about the best time to enter a contract, and we will actually do a trade. Do an options trade. Okay. All right. Well, we'll see you then. And thank you for watching. Please like and subscribe.